There we go. So what I mean by a small part of our unit circle is, if you think about it, your unit circle has root 3 over 2, root 2 over 2, 1/2. Even 1/2, y'all hate graphing because it's a fraction. It's half. And then you also have zeros, ones, and negative ones. So out of all of those, what would you rather graph? Zeros and ones and negative ones, okay? And those are located on our X and Y axis. So that's exactly what we'll use. We'll use those ordered pairs. And that's what we will use to graph, okay? So we will fill in this little chart here as we go. You did a little bit of it. And I'm going to do this the same way I want y'all to do it in your notes, because I don't want y'all drawing dash marks for the whole thing, okay? So again, I want to stay at my 0, pi over 2 pi, 3 pi over 2, and 2 pi. So that's how I'm going to label my x-axis. And we're going to go backwards with that too. Every single one of our graphs we're going to draw today are going to look the exact same. The only thing that's going to be different, it's going to be how you label your x-axis, okay? So if you do not label your x-axis, I have no way of knowing what your graph actually is, because again, they're all going to look the exact same. It's not like when we were graphing parabolas and they look the exact same in shape, but then like we noticed when it was narrow or when it was wider or like things like that. These, like I said, you'll notice they're going to look the exact same, except I might not have pi over 2 where pi over 2 is. I might have 4 pi there. But if I drew it to scale, it'd be off the charts, okay? So it's just labeling is key here, all right? So what was the highest and the lowest you were able to go with your spaghetti graphs? Range-wise. Do it. On your range of your graph, what's the highest and lowest you were able to go? 1 and -1. So for sine, we're going to go from -1 to 1. And a lot of y'all got this part right. You read it in words, but yes, the domain is all real numbers. Okay. So on our graph, like I said, we'll kind of come back and forth to this chart to fill it in. On our graph, we're going to go as high as 1 and as low as -1. So I could stretch my graph to 17 if I wanted to. And if I put 17 right here, it would look the exact same as if it was 1. Okay, so it doesn't have to be drawn to scale. You just have to make sure it's labeled.
So how do you know what to use for like the labels?
That's what we're going to do. So right now you are just learning the parent function of sine. We're going to do transformations here shortly. All right, so if we are doing the sine function, is sine your x or your y? Y. So what I would do when I have my zeros and ones off to the side, I kind of highlight my y values, just so I don't get confused. And let's start at 0. What is my y value at 0? Oh, they're energetic today, aren't you?
0.
Thank you. Okay. At pi over 2, what's my y value?
1.
Thanks, Dane. Coming through. At pi?
0.
Woo! 3 pi over 2?
1.
Negative 1. And back to 2 pi.
Should have left it to
What's the last one? 2 pi. 0. Now, I could go backwards. If I start at 0 and I go backwards pi over 2, I get negative 1. But if you notice, there's a pattern. Some teachers will teach it 0 high, 0 low, 0 high, 0 low, 0 high, 0 low, okay? For your sine graph. And now we just make our wave. What is that symmetric about? The origin, which makes it what, even or odd? Odd. Origin is always going to be odd. Which if you knew your even and odd functions from our identities, you would also know that. So the period of the function is almost like, where can I cut the equation and be able to copy paste it over and over and over again? Okay, what is the distance of this graph that I could cut it out and literally copy paste, copy paste, copy paste, copy paste? 2 pi. Good. So if I take a distance of 2 pi here, I could take that green squiggle, if it was drawn to scale and everything matched perfectly, I could copy paste it over and over and over and over again to continue my graph. Okay? So the period of the function, like I said, this distance here is from 0 to 2 pi, so it's 2 pi. The definition says 1 complete cycle. Okay, so you have your high and you have your low. Okay, that's our sine graph. Cosine, we're going to do very similar. So go ahead and set up your x and y axis just like the one we did for sine. So now we're looking at our cosine value, which is our x value. So our x value at 0 is just 1. Pi over 2, it's 0.
What? I already answered. I should know.
At pi, it should be -1. And if you notice, it's going to be the same pattern. So when we start graphing these with transformations, once we get 1 or 2 dots going, if we labeled both our x and y axis correctly, then we'll just continue the pattern. Okay? So it kind of goes against a lot of what you've learned and all, not goes against, but like everything you've done in other classes, of math classes, where you pretty much don't label your x and y axis. You got away with that a lot of times. This time it's key. You have to do it. So a lot of times you'll find that we'll do a lot more work before we actually graph something, but it's to make it easier on ourselves. So let's go back to that chart. Same thing. All real numbers from -1 to 1. Same distance from 0 to 2 pi. I could take that, copy paste it over and over and over again. And what is this one symmetric about? So it is
Even.
There he is. Just trying to give the listeners what they want.
Me?
Yeah.
You sure?
Yeah, it was in the comment section.
Oh, was it?
Uh-huh. Playing Wordle while we're learning math? Words? Oh, man. The best part is I call him out on it and he still continues because he's like, I'm not giving up on this thing.
He has 2 greens, he can't give up.
Yeah. It's like the whole thing.
He has 2 greens. He cannot give up.
Only in the second round. It's like the whole thing.
Don't give away
He has
answers.
3 letters.
Yeah.
All right, so if you don't write down the top part, you won't know what A, B, and C, and D mean when I'm referencing them. So go ahead and make sure you write those down. So transformations are, in theory, technically the same exact transformations we've been doing this whole time. You have your vertical stretch and compressions on the outside. You have your up and down. The only thing that's different is your left and right. They wanted to mix it up a little bit. You're still going left and right, and it's still located in the same spot inside the parentheses, but it's called a phase shift. And you no longer just take the number, like in this case, you don't just take C and say it goes left and right. Okay, we have to do a little bit more than that. But everything else is the same, okay? So A, of course, is going to make your graph stretch or compress vertically. All right? So our range is going to be between a -A and a +A. Think about all the science classes you've had before. If I am looking at this wave that we have now created, Okay. Thinking about stretching and compressing vertically. Let me give you a visual for that. If I am stretching or compressing this vertically, what is that changing on the wave? But what was the distance between those two called? The amplitude. Okay. So amplitude is still a thing. All right. So A should help you remember amplitude. The absolute value of it is our amplitude. So in other words, your amplitude can never be negative. Kind of like how I told y'all reference angles can't be negative. Then y'all still circled the negative answer. Okay, so the absolute value of A is your amplitude. So when we were doing just sine and just cosine, technically there's a 1 in front of it, and that's why our amplitude was 1. Okay? So the period of sine and cosine we talked about was 2 pi. Okay? But that can change, and it can change if we have a B value. Okay? So if we have sine of 3x, or actually let me do it this way. If we have sine of 4x, B is 4, 2 pi over 4 becomes pi over 2. So what used to take a whole distance of 2 pi to give a full cycle of the graph now happens in a distance of pi over 2. Okay? So horizontally it compressed, which makes sense, okay, from all the transformations we've been doing in the past. So what used to take 2 pi to go all the way up and all the way down now only takes a distance of pi over 2. Okay, so the period of the graph changed when there's a B value other than 1. Okay? And you'll see that in some examples that we do. This is more of just the notes part. Okay, so let's first look at if we have an amplitude change. Also, it is stretching the graph vertically or compressing and all that stuff. So transformation-wise, we would have looked at this and say that it's going to take our graph and it is going to compress it vertically. So nothing is different except when you make your X and Y axis. Instead of labeling this as 1, we label it as 1/4. So it's literally going to look just like the graph we just drew, except we labeled it as 1/4. The only way these would look different is if you had graph paper. Oops. If you had graph paper that was the same and you had all these graphs next to each other, you would be able to see the difference. Okay, so go ahead and graph that using your 0, 1s, -1s. In some cases on your homework, they're going to tell you to graph 2 periods of the function. That's why I go into the negative. It doesn't really matter if they don't specify a positive and negative, then you could keep going forward if you wanted to. But that's what I usually do, because that's considered technically 2 periods of the function. 1 here and 1 here. All right, so cosine at 0 is going to be 1. And technically it would be 1 times 1/4. So what you're doing is just like you've been doing in all your other graphing things in the past, is I am literally plugging in 0 pi in this case. And I'm evaluating what is cosine at 0. It is 1. And then I'm taking 1/4 times that 1. Okay, so that's how we're evaluating these, but we're doing it. So we know that our graph is going to keep following this pattern. But I can do that because I have my x and y axis set up correctly, that I don't have to evaluate from there on out. So it looks just like the one we did. Looks like the same size. It's actually compressed. But I can denote that by just making sure my y-axis shows that. Okay? So amplitude change really doesn't really do a whole lot. It's when we get into the period change of the function and then phase shifts left and right. Okay? Any questions so far? All right, so let's check this one out. Don't set up your x and y axis just yet. You can set up your y axis, but not your x axis just yet. Okay, so my b value in this particular case is going to be 1/2. Remember, we can rewrite this as 3 sine of 1/2 times x. They just write it as x over 2. So my b value in this case is 1/2. So if I want to figure out what the period change was, I'm going to do 2 pi over b, which in this case is 2 pi over 1/2. Multiply by the reciprocal. What's the new period of the function? 4 pi. So what took a distance of 2 pi is now going to take a distance of 4 pi. Okay? So how do we set up our x-axis? Simple. You what?
It's pi, 2 pi, 3 pi, 4 pi.
How'd you get that?
I just multiplied it over 2.
Okay?
That's
The quickest way to figure out how to set up your x-axis, and you're correct with what we set it up as, is take your period of your function, the new one, divide by 4. Okay? When you divide it by 4, we get pi, 2 pi, 3 pi, 4 pi. So take the period of the function, and that's going to tell you what you go by. And we're going by pi. So that's why it's 1 pi. Then we add another pi, we get 2 pi. Add another pi, we get 3 pi. And so on. So that sets up your x-axis for you. Now, if I plug in 0, sine at 0 is 0, times 3, still 0. If I take pi and I plug it in for x, I can plug it into this one up here because it's better than doing it here. That just becomes sine at pi over 2. Okay? Well, notice that takes me to my next spot of my zeros and ones. So by doing this, where you take the period of your function, divide it by 4, it's going to keep you in these 4 that we've been using. And it's not going to stray you away where you're having to do like root 3s over 2s and root 2s over 2s. So sine here is 1 times 3. And then like I said, if your x-axis is set up correctly, you can continue the graph. So that would be a situation where they tell you can do like 1 period of the graph. If they want to, you can keep going to the right or to the left. So if I was to plug in 2 pi, I would get find sine at pi, which is my next. So I'm just going around the circle like I've been doing. Sine is 0, 0 times 3, 0. So I can keep going that way. Okay. Which technically we were doing in the previous problems. I just went ahead and set up the x-axis for you. If you notice, the period of the function was 2 pi. Well, if you take 2 pi and divide it by 4, you get pi over 2. What have we been going by in each one of the problems? Pi over 2. Okay? But I set it up for you and I said, do this, and you did it. But that's what we were doing there. Okay? So, and those are the same up above, so you don't have to rewrite those again. But the graph completes 1 full cycle from 0 to 2 pi. We've talked about that. All right? Now, what if the graph shifts left to right? So it's no longer from 0 to 2 pi, it's from, if we shifted pi over 2, it's now from pi over 2 to 2.5 pi, or whatever you want to call it, 5 pi over 2. Okay? So, how do we do this? We are going to take what's inside the parentheses, and we'll set it equal to 0 and 2 pi. Bless you. By evaluating this, you find where you start on your x-axis. And this tells you where you end on your x-axis. And we already talked about divide into 4 equal parts. Period is 2 pi over b. This is kind of repeating what we've talked about. And the graph is shifted by b x minus c. Oops, I don't know what all these, that's my shirts. So stuff we've already talked about, but in case you want to fill that out. So this tells us where we start. This tells us where we end. And dividing the period by 4 tells us what we go by. Okay? So you're doing a whole lot more work on the front end just so you don't have to graph root 3 over 2, root 2 over 2. That you can simply just go 0, 1, negative 1, 0, 1, negative 1, 0, 1, negative, and so on. Okay? All right. D tells the graph goes up or down. I mean, there's nothing fancy about that. So Again, it still does it vertically. If it's positive, you go up. If it's negative, you go down. That has not changed. So really the only thing that's changed is your phase shift, your left and right, and then the period changes the graph. But other than that, transformations are still the same. Okay. So let's do some examples. First, what I want you to write out is any of the little details that we're going to talk about. Tell me the amplitude, tell me the period of the function, and tell me the phase shift. And I'll show you the 2 different ways they want you to write the phase shift. Just depends on who's grading. But if you're taking a multiple choice test for the state test, it'll be obvious. Oh, we do have a test date for your state test. I don't have any seniors in here, right? I think I have just juniors and some. Okay. Because it's during senior exams, so that's why I asked that. May 16th at 8:30. So, as of right now, and I'll double check because I have to confirm with the higher ups. As of right now, I've kind of been given a leeway of not having 7 a.m. the day of it. If they do force us to, then we'll just kind of review. But it'll be at 8:30 in the library, so you'll miss your first block that day on H day. Yeah, H day.
Darn it.
Your first block, and maybe in the second, I can't remember the exact time. It's like,
Please miss second.
I think an hour, I think it's 2 hours, I can't remember, that they give you.
What day is this on?
I'm sorry?
What day is it?
It is the 16th of May. So,
What's the final of this?
what's what?
What's the last day?
Very close to that. Maybe.
Our last class in here will be that Friday, so we'll take that test Monday. So we'll have Wednesday and Friday left after we take that test, which is ideal because I can get all the material to y'all. And it's not like we take it in February, it feels like, and then have to babysit for the rest of the amount of time. But yeah.
Wait, the test is on a Monday?
Test is on a Monday, which I'll try to remind y'all like crazy. And then we'll have our exam. I don't know what we're going to do that day on that Friday. And then we'll be done with this class. Now, the last day for exams are going to be on Tuesday the 24th. Makeup, so the 25th.
We're going a little late this year. No, I just got it early.
Huh?
My last day last year was the 20th. So when you started talking about the 23rd, 24th, it's like that's late last year.
Yeah.
But
Well, senior exams are it's usually there's a good gap between senior exams and underclassmen, and there's not this year. All right, so what is my amplitude here?
Oh, 1/2.
1/2. So the period of the function, if b in this case is 1, it's still just going to be 2 pi. 2 pi over 1, just 2 pi. And then the phase shift, if I do c, which is pi over b, which is 1, I'm going to go pi, and then since it's negative, I'm going to go to the right. If you are on the state test and they do not say left or right, as a part of the answer,
Freak out.
go by positive versus negative. Okay? So I feel like the old county test used to be if they wanted you to say pi to the left, they would have a negative pi or something like that. I can't remember. It was how they did it that I was like, well, that's kind of confusing. But pi to the right. So still going to take us a distance of 2 pi, but our amplitude has compressed our graph, but we're shifting our graph to the right by pi. Sorry, your way is that way. All right? So this is how we're going to set up our x-axis. Okay, so we take what's inside the parentheses, which is x minus pi, and we're going to set that equal to 0 and 2 pi. Solve for x. This is where we start, and this is where we end. And then what we go by, we take the period and divide by 4. So we're going to go by pi over 2. Okay, so that's, like I said, we gotta do some work ahead of time that tells us how we set this up. Okay. So if we start at pi, pi plus a half is how much?
3 pi over
3 pi over 2. Plus a half. So we get 2 pi. Plus a half. And plus another half. So we get you. So even though we are dividing by 4, it's not necessarily true that we're only going to have 4 hash marks, okay? But if you start, or the start is, and you go by what you're supposed to go to, then you're going to end where you're supposed to end. Like, it just all flows together. Sounds really silly to say all that, but it really does, okay? So then now if I start by plugging in pi in for x, pi minus pi, of course, is 0. Looky there. I'm starting where I'm supposed to start. Okay? So how we do all this extra work down here, it helps us to go back to where we started. And that's our 0, 1s, and all that. Okay? So sine there is 0 times 1/2. And then, again, if you're confident enough in how you set up your x-axis, you don't have to evaluate anymore. Now, if you want to do that, finish a test, and then come back and double check what you did, you can. I can plug in 3 pi over 2. So if I have 1.5 and I take away 1, I'm left with a half, which is exactly where we wanted to go. So sine at pi over 2 is 1. 1 times 1/2 is a half. Okay? So again, if you have it set up correctly, you don't have to evaluate any more than just that first dot. Okay? And it takes some practice. Okay.
So what's that on the right, like the 1/2 sign, 45?
What's what?
What is that equation under the graph?
Right here?
Yes.
I was plugging in the next value. So if I didn't trust that I set up my x-axis correctly, I was showing that if I evaluated this, 1.5 minus 1 is 1/2. So then sine at pi/2 is 1. 1 times 1/2. So that's how I get my actual answers. Okay. So try this one. Thank you. This is also really when the fractions start kicking in. Fair warning. Also, to give you a heads up, your test for part 2 of chapter 4 won't be next week, but the next on the 16th, currently. So I'm adding a third to 2. So if you need to kind of do some side work off to the side, like a common denominator, we get 3 times 2, which is 6, plus 1 gets me 7 over 3. Okay. Again, fractions, you have to get used to them. And if we take the period divided by 4, we're still going by 1/2. So again, you gotta know how to add a half and a third. Okay. So then if I'm adding 1/3 and 1/2, get 5 pi over 6. If I want to add another half, in other words, if you notice, I am adding 3/6 each time, but then I would have 5, 3, that's 8 pi over 6, which reduces to 4 pi over 3. If I add another 3/6, 5, 8, 11. And if I add another 3/6, I have 5, 8, 11. And I should end up my 14 pi over 6, which gives me my 7 pi over 3, which is exactly what I wanted. Okay. Have to practice those fractions. They're ugly, I get it. So if I start at pi over 3 and my amplitude is 1, then if I plug in pi over 3, I get 0, sine at 0 is 0. So now I know how to start my graph. Looks just like the last one we did, but if we drew it to scale, it'd be different. So that's why it's super important to label. Label, label, label. Questions so far? Let's try this one. What is the amplitude? Not -10. Okay. The period of the function is 2 pi over b, which in this case is pi over 6. It's almost like when it becomes normal, again, because my pi's will end up canceling, that you're like, whoa, what's going on? I'm used to pi being there. Pi is no longer there. Even though a second ago, you're like, whoa, I'm used to labeling my x-axis 1, 2, 3, 4. Now there's pi. Now you're going back and you're like, whoa. So 2 pi times 6 over pi gets me the number 12. So if I take 12 divided by 4, I get 3. So what seemed to be a lot harder problem is actually easier than the ones we've been doing. Okay. So then now if I was to plug in 0 into the function, I get 0. Cosine at 0 is 1. 1 times -10 gets me -10. And then I could continue the pattern if I wanted to, but maybe I don't catch on just yet. I plugged in 3. again, it gets me to my next spot. Cosine at pi over 2 is 0. So negative 10 times 0 is just 0. Let's say I'm still not convinced. Negative 10 times cosine at 6 pi over 6, which is just pi. Cosine here is negative 10, or negative 1, sorry. Negative 10 times negative 1 is a positive 10. I could keep going if I wanted to. But I have my graph. Okay. So what seemed to be harder was actually easier. You have to deal with normal numbers, not pi. Okay. All right, let's look at one where it's got all but a phase shift going on. We're going to move the graph up, or down 4, sorry. So the amplitude has changed, the period of the function has changed, and we're moving it down by 4. See how far you can get on this one. This will be our last one. So be careful when you're looking at your amplitude and moving it down 4. amplitude's 5. I take the period of the function. I get 2 pi times 12 over pi. Which gives me 24. So if I have 24 divided by 4, that gets me going by 6. Now, if I wanted to write out my amplitude, and naturally we would have done 5 and negative 5, but we're going to have to move the graph down 4. So it changes things a little bit differently. What you could do is wait until the first one you do to fill that in. Okay. So if I was to plug in 6, actually, let's plug in 0. So we get 0. Cosine of 0 is 1. So then 5 minus 4 just gets me 1. That helps me know what to label my y-axis. Okay? Then if I plugged in 6, should get me pi over 2, which it does. Cosine there is 0. So then 0 minus 4. So I still have an amplitude of 5. It's just not at 5 and negative 5. All right, if I plugged in 12, I'm over here at pi. Cosine here is negative 1. So negative 5 minus 4. So we got negative 9. And then from there, I can continue my pattern. Okay. Or you could keep plugging things in. If you don't trust that you know the pattern and you can't see it and you're like, where does it start? Where does it go? Then you can always keep plugging in. You can plug in 18, plug in 24, and so on. Okay. Are there any questions?